What's up, you guys? In the conclusion of our trilogy here for our stack class, I'm going to finish it up by doing some operator overloading. More specifically, I'm going to overload the equals operator, the double angle brackets operator used for stood cout, and the double equals operator, as well as the not equals operator. So let's get started. Where we left off is that we finished our miscellaneous functions, miscellaneous methods, and now we will continue with the operator overloading. So first I'll begin with my operator overload of the equals. So I'm going to return to a reference of stack that has the type S. So I'm returning this particular one, and I'm going to have operator equal stack S with a reference to S, and actually I wanted to make this const. So what happens if we show like an empty stack? So if we want to assign an empty stack, so if S is empty, if it's empty, what I'll do is that I'm going to set size equal to 0. I'm going to make my current stack empty. I'm going to delete data and then set data equal to the null pointer and then return this. Otherwise, we're gonna have a case where S is going to be non-empty. So what I'm going to do is that I'm going to first check if S size is equal to 1. So if we only have one size for the stack that we're trying to copy over, what I'll do is that I'll create a temporary copy. So I'll have S value, and it'll be a dereference of our data. And I do this because if that should be S. So our S is an S value, and that's going to be equal to lowercase s dot underscore data. And here essentially I'm just copying one value, because in this case our stack little s is going to be having a size of 1. So I just need to copy one value from its data. Then what I need to do, if our own size is less than 2, meaning, well, essentially that it's 1, we're going to delete our data. Otherwise, we're going to do the element delete data. And actually, now that I show this, I want to put that right here. This is the first thing that I should do. Then I'll set size equal to 0, set data equal to null, and then return this. Now replace this with double equals to 1. So if it's one value, we delete it. Otherwise, we're going to delete everything else. We set size equal to 0. We set our data equal to null, and we return. We essentially make our own stack empty and return it as an empty stack. But then, however, if it's the size of 1, I'm going to take a copy of my one value from the right-hand side, the right-hand side being S. I delete my own internal data, and I say data is equal to new S of our S value, and size will be equal to 1. Otherwise, we're going to say, okay, well, our S data, we're going to be needing to take a copy of the entire array, because this is going to be the case where S data is going to be greater than 1. So we'll allocate the space for it, and I'll need s.size here, and to make sure that I have my iterators correctly created, this is going to be, I'm going to take a copy of this, and actually I'm going to replace this with the underscore, just so that I use the variable and minimize any method calls. Honestly, this should be negated because our size method is a const, but just in case our compiler doesn't do that kind of optimization, I'm going to do the minor optimization here. And the minor optimization being just minimizing function calls. So we're going to create our other for loop, and actually let me just create my iterator here, size ti, and then for I is equal to 0, I less than s size. We'll then copy our data to our s data. We will copy s dot data to s underscore data, but essentially I'm copying the data from the right hand side of our stack to a temporary copy. Then I'm going to delete my own internal data, so we're gonna have a repeat of this, and I'll just do that. Then we're going to reallocate some space for it, so data is going to be equal to new s of s underscore size, and then we're going to copy this data here to our internal data. So we'll have data plus I is equal to, s underscore data plus I. Then we will set our own size equal to s size, and then we'll delete our temporary s data. And that's an array, so I'm going to say that. Yeah, going to delete s data. After that case, I'm going to return this. And again, why am I doing it this way? Why am I taking some temporary copy and then deleting my own internal data and then taking the copy and sending it equal to my internal data? Before, I mean, with the other classes that I had, like rectangle, pyramid, and all that, I did a direct setting because those are just constant variables. For here, when we have dynamically allocated data, we're preparing for both the case that we have two distinct stacks, where the right hand side of the stack is being set equal to the left hand side, where both the right hand side and the left hand side are different stacks, but we also need to be able to set a stack equal to itself, right? We essentially need to be able to do like A equals B as well as A equals A and B equals B without breaking our code, because you can do the same thing with integers and floats and strings and the like. Our goal should be to replicate this with our class. And that concludes our equals operator. Next, what I'm going to do is I'm going to declare some friend functions. So I'm going to have my template type name s friend output for our favorite operator for printing. So we'll have our O stream here, make this out, and then const stack s, and we'll have a constant reference to that. So here I'm just going to declare it. Outside, I'm going to show you two things that you can do. So here I'm just declaring the friend function, and I can implement it if I wanted to, but I'm not, just to show some variety. However, here I will show some variety. So we'll have const stack s a const stack s b. So first thing I'm going to check if a size is not equal to b size, we're going to return false. Hopefully most of the time when this is called, it's going to return this. Otherwise, we're going to have to do some work. So I'm going to create my iterator I, set it equal to 0. We're going to say I is less than a.size. It can be b. Here the assumption is that they're both the same. And then if a data plus I is not equal to, oh shoot, let me put some extra parentheses here so then we know exactly what's going on. So here I'm making sure that I access the data inside of my stack and nothing weird and ambiguous goes on. So then here on my left hand side, I'm going to make sure that I'm accessing B correctly, or I guess more explicitly. But in any case, here if they're not equal to each other at any point, then they're not equal at all, so we'll return false. And only when we exhaust that, we will return true after. So let's take a quick overview back. We have our double equals operator, so in order for our stacks to be equal, let's consider if it's true, then they both need to have the same size. If they don't have the same size, then, well, they're not equal. Well, now if it turns out if they do have the same size, then we need to check the contents. So I loop through every single data point inside of A and B at the same time. And if at any point they are not equal, well, then our stack is not equal. So then I have this if statement to return false. It is only when we iterate through the entire loop and this is false all the time, well, that means that every single element of A that's inside of the stack is equal to every single element of B that's inside of the stack. So we have no other choice or no other option but to return true. That's the idea here. Is there another way to implement double equal sign? Probably, but this is the way that I'm thinking about it. And then here we're going to move on and we're going to have our not equals operator. And actually this is going to have the same arguments as this. We'll just slap it on here at the bottom and end it with a semicolon. So what's going on here? Now I've just declared like 3 of these operators, and these are friend functions. So I mean, these are like independent functions. So I'm going to need my template type name s. So that way this S matches the S that I create. So if I create a float stack, my compiler will generate code for comparing 2 float stacks and for comparing 2 non-float stacks. let's say for example that, well, I mean, if they're not the same data type, they might not be exactly comparable, so I won't go there. I was thinking of something, if we had maybe like two data types, we can have like S and type name T, and then say friend bool operator not equals const stack S, which again we'll call A, and then like a const stack T, which we'll call B. So we'll be able to, here, I mean, we're declaring that consider two different data types, and if I can spell type name correctly. But I don't want to go here because more often than not, figuring out that these two have a comparator for not equals is not so likely. So it's gonna, I think it's an unnecessary challenge. But anyway, so here I define these three friend functions and I only implement one of them. So what's gonna happen to these two? Well, after I'm done with my class here, I can go and implement them outside of the function. And this is why I wanted to show it this way. You have two options when it comes to implementing your friend functions in this header file. You can do it within the class, or you can do it outside of the class. So here I am, and actually I need to get rid of the friend. So then here, oh man, let me do that. So here we're gonna have our out for size t of I equals 0. We'll iterate through our stack size and we'll access it just directly. Print out this. This will be s data plus I, and then I'll have a space, and then I'll return out. That's what I'll do here. Right, I iterate through the internal array that's inside of the stack and I print it out as is. I store it all into out and then I return out. And then for my bool, or my not equals operator, my bool. So I'll have type name s. I'm going to copy this so I can be lazy, and then I'll get rid of all that. And then I'm going to be even more lazy. I'm going to return not a equals b. This is one of the reasons I love overloading the equals and not equals operator, because I can just overload one and then put a logical not for the other. So this should about do it for all the methods and operator overloadings and stuff for a stack class. I do want to emphasize that while this does all seem neat, I don't recommend that you use this class. I'm going through this class so that way you have an idea on how it can work under the hood, kind of an application of the theory. But if you're going to really use a stack, there is a std stack that's part of the standard template library that you should use. This is better implemented, and it's completely implemented rather than my own stack class that I have here. Right, and you should be using this, not this class that I created. But anyways, this is more of an application of the stack theory that I talked about. And in the next video, I'm going to go through a main program that I have so we can test our stack class and see that it just works. If there's any bugs there, we'll crush those bugs when we get to them. Thank you so much for watching, and I'll see you for that video.